Good morning, students. So in the last class, we discussed about nomenclature of aldehydes, ketones, and carboxylic acids and their reality. So if in the same compound, as I told you, same carboxylic acid is there, aldehyde is there, ketone is there, preference is given to which functional group means carboxylic acid. It is the pure functional group. Okay, if any other functional groups are there along with carboxylic acid, always the preference means the parent chain must be end with oic acid. Remaining all the functional groups are considered as substituents. In the periodic order, that is the top most. Least is that is chloro, nitro, that one. Okay. So next one is okay. The last class we discussed about the nomenclature. Next in the today's class, we are going to discuss about the nature of carbonyl group. So in all these aldehydes, ketones and carboxylic acid, we have a group like this. So in aldehyde, it is R, it is H. In ketone, both are R. So in carboxylic acid, so R and OH. In all these, the common is this carbonyl group, C double bond O. So what is the nature of that? So if reaction, any chemical reaction is going to take place or any other preparations or whatever it may be, what happens? Listen, here on the oxygen, lone pair electrons are there. Okay, so among carbon and oxygen, which electronegative means oxygen is highly electronegative. Means, so this oxygen can have the capacity to attract the pair of electron of carbon towards itself. Means this electron of carbon, if I write like this, so electrons of carbon, hydrogen, both are here only. Understand? Because this one is highly electronegative. This one is comparatively electropositive. So along the group, boron, carbon, nitrogen, oxygen. This is highly electronegative compared to this and this. Along the period, electronegativity increases. Okay, so this is the thing. So because of this, due to this different electronegativity, that polarity will exist. How? So listen here. If the electrons of this shifted here, electrons of carbon shifted towards oxygen, then what happens? Here single bond will form. Here these three lone pair of electrons will form. Understand? If such a type is there, so students here, with this is with the extra electron lines, you will get the minus charge, this will get the plus charge. The plus and minus polarity. Assume, so in any reaction, for example, KOH is there, assume, CH3OH is there. How it is dissociated, this alcohol is to be added. So we have to check which one is the electrophile, which one is the nucleophile, means which one is with the positive charge, which one is with the negative charge. So then we just match the opposite charge, means this plus charge is there, that is always goes to this oxygen atom, plus and minus. So OCH3 and OH is there, that is attached here. So whatever the reagent formula here is like this one. So here it is OH because here plus is there and here it is OCH3. This is the way how the reaction takes place in carbonyl compounds. Understood? The nature of the carbonyl compound is, of course, it is polar. Due to what? Due to different electronegativity of oxygen and carbon. So this is what the nature of carbonyl compound. Okay, so here this carbon is what? sp2 hybridized because double bond is there. Double bond is there, so that's why it is sp2 hybridized. So of course, sp2 hybridized means it is planar structure. So listen here, this is like a planar structure in aldehyde, ketone as well as carboxylic acid. Okay, so next we will go to the preparation of aldehydes, ketones and carboxylic acids. So the first one is preparation of aldehydes. Okay, so how many types are there? Initially I tried that. So first one is dehydrogenation of alcohols. Dehydrogenation of alcohols. First one. In the second one, okay, Rosenman reduction. This is from acyl, especially acyl chlorides. Rosenman reduction. Okay. So the next one is Stephen reaction. Next, this is from nitriles, alkyl nitriles. Okay. Next, fourth one, Ethards reaction. Ethards reaction. This is alkyl substituted benzene. Alkyl substituted benzene. Okay. And the next one, okay, this is enough. The next one is there. That is Gattermann-Purge reaction. So whatever the reactions I wrote with the name Rosenman, Stephen, Ethard, Gattermann, all are very, very important for 2 marks. Preparation is both. Okay. So listen, this chapter maximum it is consists of more than 17-18 named reactions. Okay, and all are important. Here only it is already 4 plus 1 5. So more than 17-18 reactions are there with the mechanisms like aldol condensation, cross-aldol condensation, like so many other esterification is there. So be thorough with it. Very important chapter because for your syllabus, not even a single point is removed from this chapter. That much very important it is. Okay. So we will go with one by one. So preparation of aldehyde. Aldehydes with the functional group C double bond O H or CHO. This functional group we have to prepare from alcohols, from acyl chlorides, nitriles, alkyl substituted benzenes, and this Gattermann-Purge reaction. This is also from benzene. Understood? So we'll do it one by one. So students, first one is dehydrogenation of alcohol. So I'll take the example of alcohol, that is primary alcohol I take. If secondary alcohol is there, what happens later I will say. So primary alcohol R CH2OH. So here what happens? Dehydrogenation. D means of course removal. Hydrogenation means addition of hydrogen. Dehydrogenation means removal of hydrogen. Hydrogen is removed in which form? In H2 form. That is dehydrogenation. So we have to remove 2 H2 molecules from here. Okay. So of course one H is removed from here, another one H is removed from here. Okay. Then we form R CH double bond O. Nothing but RC double bond O H. Are you getting? So you can simply write it as RCHO. Aldehyde we are getting. By what? Dehydrogenation of alcohol. If it is primary alcohol, then only we have to get aldehyde. If it is secondary, then what happens? RCH CH2 OH. Okay? So listen here. One H is removed from here, another H is removed from here. Then what is the product formula here? R C double bond O CH3. This is a ketone functional group. So in the secondary carbon atom we are getting what? ketone. Understood? So for preparation of aldehyde, the main thing you have to remember is what? We have to consider only primary alcohol. So you may check the, what is that? Chemical properties of alcohol. In the chemical properties of alcohol, I already told, so upon dehydrogenation, primary alcohols gives aldehydes, secondary alcohols gives ketones, tertiary alcohols gives alkenes. That already I told. How? Listen, I take the example of tertiary alcohol here. This is CH3, 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 OH. Here, dehydrogenation cannot be takes place. Here, dehydration takes place. Because here there is no hydrogen to remove. So that's why here OH is removed. From any one of the carbon atom, H is removed. So of course they form double bond like CH3, C double bond, CH2, CH3. Okay? Primary I already wrote here. Secondary. So from primary alcohol aldehyde, secondary alcohol ketone, tertiary alcohol alkene. That we are already discussed in chemical properties of alcohols. You may check there. Both are same. Their chemical properties is the preparation of this. Understood? Okay. So we have to use primary alcohol. So upon dehydrogenation, they give. So for dehydrogenation, we are using any acids, H+. Okay. So next. So for example, if you want to take anything, you can replace R by any alkyl or aryl group. Alkyl means any CH3, C2H5, whatever it may be, straight chain, aliphatic compound. Aryl means benzene ring compound. You may replace R group by any of the following. So I'll give one example and just replace R group by CH3. CH3, CH2, OH. What is this alcohol called as? Two carbon atoms are there. So that's why it is ethanol. Okay, so when it is undergoes dehydrogenation, gives CH3, CH4. This is also ethanol. It is ethanol. It is ethanol. Understand? Plus H2. This is in what? In case of aliphatic compound, straight chain compound. Don't bother about this R group, whether it may be a very long chain molecule or a short molecule or any tertiary, primary, secondary. Only the reaction takes place in between these two. So and remember one thing, here you have where the OH group is attached to that carbon, at least one hydrogen we require. Understand? So we require at least one hydrogen to remove, either to form aldehyde or to form ketone. If there is no hydrogen, remember, so that is always a ketone, alkene. ಇಲ್ಲಿ OH group ಅಟ್ಯಾಚ್ ಆಗಿರುತ್ತಲ್ವಾ ಅದ್ರ ಪಕ್ಕ ಇರೋ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಯಾವಾಗಲೂ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರಬೇಕು. ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇದ್ದಾಗ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಏನು ಉಳಿಯುತ್ತೆ? CHO ಉಳಿಯುತ್ತೆ. ಸೊ ಆಲ್ಡಿಹೈಡ್. ಇಲ್ಲಿ ಓನ್ಲಿ ಒನ್ ಹೈಡ್ರೋಜನ್ ಇದೆ ಅಂದ್ರೆ ಎರಡು ಹೈಡ್ರೋಜನ್ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಓನ್ಲಿ CO ಉಳಿಯುತ್ತೆ, ಮೀನ್ಸ್ ಕೀಟೋನ್. ಸೊ ಇಲ್ಲಿ H ಕಂಪ್ಲೀಟ್ಲಿ ಇಲ್ಲ ಅಂದ್ಮೇಲೆ ನಾವಿಲ್ಲಿ H ರಿಮೂವ್ ಮಾಡಿದಾಗ ಇನ್ನೊಂದು H ರಿಮೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ಸೊ ಆ ಟೈಮಲ್ಲಿ ಕಂಪ್ಲೀಟ್ OH ನ ರಿಮೂವ್ ಮಾಡಬೇಕು, ಅವಾಗ ಬರೋದು alkene. That is the way you have to remember. So listen, I'm not telling. So in the examination they are giving only this example, ethanol or any this type of reaction. They won't ask directly. Okay, they may ask if tertiary alcohol undergoes dehydrogenation, what is the product form? Then you need to know how to write the tertiary alcohol. Okay, how to write the what is the product form and how to write the mechanism and what and to which it is belongs. Understand? So next, if they ask, so write the reaction for preparation of aldehyde from alcohols. Okay, then you have to remember, of course they are asking aldehyde means I have to take primary alcohol as a reagent. So if they ask, write the reaction for the preparation of ketones from alcohols. So they are asking ketones means I have to take secondary alcohol as a reagent, then only we can get ketone. That you have to remember. That is the main thing you have to concentrate on this organic chemistry. So as I told you before, you know, in solid state 3 derivations are there, among 3 anyone is compulsory, of course, right? In these reactions also anyone is compulsory, but they won't ask directly like derive and write a Stephen reaction, directly write a reaction, they won't ask like that. They'll give the reagent and the reactant and the reagent and what is the product form. In like that way they are going to ask. Understood? For example, I told you, they won't ask Rosenman reduction here. They'll ask, write the reaction of preparation of aldehyde from acyl chlorides. From acyl chlorides means you have to remember that, of course, it is Rosenman reduction. These reactions are all important. Always they are going to often asking in the examination, but the asking way is different. They ask directly, they ask indirectly. If they ask indirectly, they ask through the question, reagents, reactants, or products. Okay, so later you will understand. So this is what. If I take an example of any benzene aryl compound, this is CH2OH side. So here one H is removed from here, another one H is removed from here. So this is the benzene ring with CH4. So this is benzenol. This is benzoyl alcohol. Remember, benzoyl. If our benzene thing is attached to any CH2, that is called as benzoyl. Sorry, not benzoyl, benzyl alcohol. Okay, benzyl alcohol. Benzyl means this benzene ring is attached to one carbon. What is benzoyl means? If this is attached to COCl, this is benzoyl. COCl, acyl halide is there. This is benzoyl. This one is benzyl. ZYL. Only third best difference you have to remember that. Okay. So this is what? Preparation of aldehydes from what is that? Alcohols. Only primary alcohols give aldehydes. Of course, from this you can easily know from alcohols ketones can also be prepared. Okay. The second one is Rosenman reduction. So very important as I told you. So this Rosenman reduction. So I'll take the general example RC1 Cl. Okay, so those are what? This R group must be especially you take benzoyl because Rosenman means you only consider particularly you did an experiment on this benzoyl chloride. Okay, so benzoyl chloride. You can take R here, but as it is a Rosenman reaction, so if we conducted the respective experiment only by taking this reagent. Okay, so when it is undergoes hydrogenation in presence of palladium as a catalyst and BaSO4 as a catalytic poison. Remember this is very important. BaSO4 in the Rosenman reaction. It is used as catalytic poison. Why? So listen here. We have to add H2 here. Understand? So here CH4 we need. We have to remove Cl. Means we have to replace only this H by here. So here how much fast this reaction is means. So this can form CH3 by removing H2 on CH here. Understand? This reaction is how much fast means. So if hydrogenation takes place, so this is completely converted into what? CH3. If we didn't control the reaction, this is completely converted into what? IR alkane. Benzene attached to CH3. Means O also removed, Cl also removed. So to control that reaction, we are using this BaSO4. That is what? Catalytic poison. It is used as a catalytic poisoner. This is the catalyst. So this is used as a catalytic poison. For what? To control the reaction to prepare aldehyde. Means only one H is replaced here. So how we require aldehyde means of course the benzene R group remains as it is. The C double bond O also remains as it is. Here one H is attached here and this here is removed. This is the reaction takes place and it is quite easy. So what is the definition of this, explanation of this reaction? You have to write that. So when benzoyl chloride, especially benzoyl chloride only, undergoes hydrogenation, in presence of palladium catalyst and BaSO4 as catalytic poison gives benzene. Okay, so this reaction is called as Rosenman reaction. Rosenman reduction reaction. So students, in this case you can answer right when benzoyl chloride undergoes reduction. In the place of hydrogenation of oxygen or addition of hydrogen. Here addition of hydrogen taking place. Understand? So that is reduction reaction. When the benzoyl chloride undergoes hydrogenation or reduction in presence of a palladium catalyst and the BaSO4 as a catalytic poison gives benzene. This reaction is called as Rosenman reaction. And remember, so here the reagent used is BaSO4, barium sulfate. But the thing you have to remember is, in the need they want us directly BaSO4. Sulfur compound, halogen compound, oxygen compound, like that they are asking. And remember, which one acts as a catalytic poison means mainly sulfur compounds. Sulfur compounds always acts as a catalytic poisons. So this BaSO4 is acts as a catalytic poison because sulfur is present. Understand? So in particularly in a key manner, if you want to remember, main reason for poison character of this BaSO4 is presence of sulfur. Not only BaSO4, only sulfur. It may be PbSO4 or any other. If sulfur compounds are there, those are acts as a catalytic poison. So this is what Rosenman reduction. If you write this much, you will get 2 books. And this are compulsory. If you cannot write this, okay, you have to mention the name here, like benzoyl chloride and this condition and benzene. Okay, that is compulsory. If you simply write this without writing name of the compounds, then you won't get any marks. Or if you are not writing any name here, you have to explain this. Understood? Okay. So the next one is Stephen's reaction. Okay. So students, to this Stephen's reaction, nitriles are the reagents, are a reactive species, means RCN compounds, nitriles. So they treated with stannous chloride, SnCl2, in presence of HCl. So initially they converted into imines. Initially they converted into imines. What is that imines? That is R, CH, double what? NH compounds. Okay, so this R, CH, double bond NH compound undergoes hydrolysis. Undergoes hydrolysis. Or here only you can write hydrolysis. This is the second step I am taking, but here only you may continue like hydrolysis. So you are writing hydrolysis means they form R CHO plus NH3. R CHO plus NH3. Are you getting? So this is the reaction taking place when this Stephens. So this reaction is called as Stephens reaction because he is going to conduct this experiment by using these reagents to the formation of the aldehydes. Okay, no matter they are primary, secondary, and tertiary aldehydes. Okay, so there is a aldehydes. What are these compounds called as? Alkyl nitriles. Okay, stannous chloride, HCl. They form imine. This imine undergoes hydrolysis, form aldehyde. Understand? So this is the reaction. How to explain that? So okay. Nitriles are, here listen, Cn is there, to the both carbon and nitrogen, H is added. Correct? So that is our addition of hydrogen takes place means reduced. So nitriles are reduced to imines by treating with stannous chloride and HCl. Okay? Upon hydrolysis, they give aldehyde along with ammonia. Okay? This reaction is called as Stephens reaction. This reaction is called as Stephens reaction. Understood? So in the place of R, you may replace N. Finished? So listen, this RCN compounds can directly convert into RCHO compounds. So by using another reagent, diisobutyl aluminium hydrides. Diisobutyl aluminium hydrides. Okay, so this is the reagent upon hydrolysis gives RCHO, means here same reaction takes place like addition of course imine forms after hydrolysis RCHO forms. Here the reagent for what is that hydrogen. Okay, as a reduction reagent used here was diisobutyl aluminium hydride. This is the reagent. Upon hydrolysis, they directly give RCH. Remember this one also. Understand? Okay. So students, next one is these two reactions are preparation of aldehydes purely from hydrocarbons. So this is from acyl chloride, this is from alkyl nitrides. These two from hydrocarbons. Okay, third reaction and as well as the term one fourth reaction. So listen here. So this ketone reaction is fourth one. Here the reagent is methyl substituted benzene. Methyl substituted benzene. It is also a hydrocarbon. There is no functional group here. R. Okay. So when it is treated with this oxidizing agent. Okay, what is it? Chromyl chloride oxide. Chromyl chloride oxide. Chromyl chloride it is. So it is an oxidizing agent. Oxidizing agent means what? Addition of oxygen or removal of hydrogen. Here CH3 is there. We want CHO. We have to remove 2 hydrogen. We have to add 1 oxygen. So what is the reaction takes place here? So listen. Initially, this one is completely attached here. That is CH. Okay. 2 hydrogen atoms are replaced by. So not replaced, this is completely added here. O, Cr, O3, H2, Cl. Are you getting? CH3 is there. So Cr, are you right here? Cr3, Cl2 along with H2. H2 of what? This hydrogen. CH, 2 hydrogens are here. Of course, this is added here. Cr, O3, Cl2. Okay, so here the solvent used is what? Carbon disulfide. Hydrolysis. So H3O plus will remove from here. Okay, what we want? Initial element, what we want. So first one is what? CHO. Here CHO is there. Correct? Next, Cr O2 plus 2H. Are you getting? CHO, Cr2 plus 2H. So here in this, it is in okay. Of course, here it is in +6 oxidation state. Here it is in +2 oxidation state. Understood? So here gain of electron reduction takes place. That's why it oxidizes this benzene. Understood? So remember here what happens. So if I write, we are considering the hydrocarbon. This hydrocarbon is oxidized by what? Chromyl chloride in presence of a carbon disulfide as a solvent. They form a adduct. So once the intermediate form by the removal of by the hydrolysis. Okay, we take hydrolysis here. So by the hydrolysis H3O plus. So then they form CHO. Means this all remote addition of CHO takes place. This is what? Keton's reaction. Preparation of aldehydes from hydrocarbons using specially not hydrocarbon methyl substituted benzene. Then only it is called as Keton's reaction. It's not a R compound. Instead of this, if we are using this CH3, CH3, then it is not a hard reaction because you won't take reagent this. You take a reagent, this methyl benzene as the reagent, not this one. So then it is not said to be a hard reaction. Understood? So these reactions in this chapter are not general reactions any other codes. Okay, these are fixed reactions. So here, explanation if you want to write means methyl benzene are united bromine chloride oxidizes methyl benzene to aldehyde in presence of carbon disulfide as a solvent. Okay, this reaction is called as Ehard's reaction. This reaction is called as Ehard's reaction. Okay. Next. Last one is Cutterman-Koch reaction. So students, this Cutterman-Koch reaction, of course the reagent used here is what? Benzene. Okay, so this benzene is treated with carbon monoxide in presence of HCl and anhydrous aluminum chloride as a catalyst. Okay, so this benzene treated with carbon monoxide in presence of HCl and the catalyst is anhydrous aluminum chloride. Or you may take copper chloride also. Both are okay. Aluminum chloride or copper chloride. Of course, the direct reaction is here. Listen. Here, so benzene here is sorry C6H6 means here one H is there, right? C6H6 means for any of the carbon atom one H is attached. C6 here C6H6 for each carbon atom one hydrogen is there. So here what happens? This C4 is added to that. And HCl is of course removed. Okay, CH2 is added to that. So HCl is removed. Okay, with this Cl is more here. The mechanism is different. So in this AlCl3 forms what? AlCl4 plus here it is plus H plus. So this is involved in the mechanism to add this CH4. So this H is removed, that H is removed, and this Cl minus is there. So this one is minus. AlCl4 minus. This is the reagent alcohol. So how it is? So this is H plus plus Cl minus is there. So this AlCl3 accepts this Cl minus forms AlCl4 minus. This is the catalyst. It is not involved, but it increases the rate of the reaction. You know that. So AlCl4 will form. So that will later convert into again AlCl. So this H plus and this CO, this H plus acid helps for the resonance and the addition of CO. So this will happen. CH4. Understand? This is completely what? Cutterman-Koch reaction. Only this much. If you write this benzene and the second, then you will get aldehyde. So this is the Cutterman-Koch reaction. Only one step reaction. Understand? So how to write? When benzene treated with carbon monoxide and HCl CuCl as a catalyst form aldehyde, especially benzaldehyde or benzene, or if I take benzaldehyde, this reaction is called Gutterman Koch reaction. Gutterman-Koch reaction. Okay, so these five are the reactions of preparation of aldehydes from the respective compound. This is from alcohol, acyl chloride, alkyl nitrate, hydrocarbon. Especially methyl substituted benzene, and this is benzene. Okay, so in the tomorrow's class, we will discuss with either preparation of ketone or carboxylic acid or the chemical properties of aldehydes. Okay.